All right, so we're on page 83 of our packet. We're looking at nets and surface areas. I also want you guys to have this formula sheet out. It has your basic formulas on the top, and we're going to add to our surface areas today as we work. So first thing we're going to do is name these shapes. I know it's not the best copy of them, but the first one's a basketball. What will we name it in the math terms? That is a sphere. What would half a sphere be called? Nope, try again.
Half circle.
Nope.
Circle.
Hemisphere. I heard it back there. All right. Now, I can't tell if this is a square bottom because I don't see the dimensions. So I'm going to play it safe and call it a rectangular what? We're on the next one. It is a rectangular pyramid. Why is it a pyramid and not a prism? Well, it could be a square, but I'm not, we don't have the dimensions. So I'm calling it rectangular. But why is it a pyramid and not a prism?
Because it has four sides that go like this.
What shape is this side that goes up like that? Yes, it has four triangular faces. So the base of it would be a square, and if we would peel it apart, we'd have those four triangular flaps. Now, what's this guy? It is a box, but let's go mathematical. Rectangular prism. Now, you could look at this as the base and the top is the base if it's sitting this way. Honestly, we can flip it any way. We could flip it so it stands up tall, base and base. But you guys are right. It is a rectangular prism. All right. The Rubik's cube. And we know it's a cube because it has 6 equal square sides. All right, number 5, you put ice cream in it. It's a cone. It's supposed to look like one of those waffle cones or sugar cones. It is soup, but what would we mathematically name it?
Soup.
Nope, try again.
Campbell's tomato soup.
I know, name brand and everything. Fancy schmancy. It is a cylinder. All right, so we're really proud that we've made it through elementary school. Congratulations.
No.
Let's do our surface area. Surface area. All right, surface area is the total area of all the faces and curved surfaces. So in a cone or a cylinder, you'd have a curved surface. All right, and so surface area is a 3-dimensional figure. We're really like, what would it take to paint the outside of it? All right, 2 ways to find surface area. One way is to draw a net shape of the figure. So draw a net of the figure. Now, the nets are when you basically unwrap it. It's what we cut out yesterday and folded up. So one is draw a net of the figure and look at each specific side, each piece, each shape. The second is to use a shape-specific formula. And there are some that we have formulas to. Honestly, the third way would be to visually look at it and say, okay, I have a cube, so I'm not going to draw the net, but I'm picturing that I have 6 of the same sides. With the cylinder, I can sort of picture what I have and think about it, but the nets really do help sometimes. All right, so we're on the next page, and we're looking at our net figures. So visually, since you guys are sitting here in class, this is going to be a cube. So if you want to hold up the cube, you can picture these 2 flaps being the top and the bottom. You see one of those sides is blue, and this is what wraps around the sides. So the base is facing you. So you have that blue side and the other side of it. And then if you wrap around where her hands are, those would be these pieces wrapping around. So this is our cube.
It's not even.
I know, and I will say it doesn't look perfectly. It's supposed to be a cube, but we could fight that it's a rectangular prism. It's supposed to be a cube, but it's stretched out. I'll take that too. Now, if it marked all the sides congruent, then you'd have to say cube. Do you see that these 2 are your bases? What shape is this? Pentagon. Now, I don't have a pentagon, but I do have a hexagon one. Is this a pyramid or a prism? It is a prism. So it's a pentagonal prism. So if you look at what she's holding up there, that orange is your base and it's parallel to the other base. And then these would wrap around and piece it together. All right, perfect. Next one. What's this guy? Because it has triangles on it. So is it a pyramid or a prism? Prism. Triangular. These are the bases. So picture folding these up just like she's holding it there. Hold it on the flat. Yeah. Just like she's holding it there. There's the flat end, and fold these up and then fold these in. It looks like a tent. So this is, you said, triangular prism. All right, next one. I don't have this, but it's much like our hexagonal prism. How many sides does this have?
8.
8. So these are your bases. Same thing. We're looking at a pentagonal one in person, or a hexagon in person, but you have these 2 octagons. Now these have little flaps. So imagine cutting this out. The little flap would fold so then you could seam it together. But you have 8 rectangles coming off of it. So this is an octagonal pyramid or prism? Prism. Yep. Okay, so let's talk about the next one. It says draw the net for a square pyramid. So look for a square base. I think it's red. So draw the base as a square. Now, so we don't have to argue about this. You had it out. It's a square. It's the cube one. Oh, it's up top. Come around. It's up on the block. So that's, oh, sorry, I lied. That's your cube. Now, instead of having the prism part, we need the ones with triangular sides. I steered you wrong. I was on cube. So it should be. So if you can picture leaving your square base and then dropping each of the triangular sides. There it is. It's a green base. There's your square base, but you only have one base in a pyramid. And then if you could imagine peeling these triangles down, it would look like this, almost like a flower or a star. Okay, draw the net for a right cylinder. Now, a cylinder is like a soup can, right? A right cylinder is one that is vertically straight up and down. So this is what a right cylinder looks like. Okay, it's straight up and down. The height is a 90-degree angle. To show you what's not right would be an oblique cylinder. It's still a cylinder, but it's pushed aside. So it's called oblique because the height, if we needed the height, we'd have to find that outside altitude. So it's almost pushed to the side. All right, now we need to draw a net. All right, so if you can hold up our cylinder, what is a cylinder made up of, guys? 2 circles. All right, so it's like a soup can. Peel off the top, peel off the bottom. What about this wraparound part? It is like a rectangle. So if you can imagine me wrapping up my cup here, that's it. Wouldn't you cut the soup can label, cut it off, and then when you open it up, it becomes a big rectangle. So here is my rectangle. And then you could draw the circles off, of here and here. You could have one circle here and one here, but the circles have to be on the 2 different sides. So this would be the height. What would be the length of my rectangle? Like, you'll get the height of the soup can, you'll get the height, and you'll get the radius. But where would I get this information? No one? Sleeping?
What?
Where would what's this? Of what? I know that, but how do I find the length of the rectangle? Because they don't give me that. Let me give you another hint. This is wrapping around my cup. And when no, it is 360 degrees going around, but if this goes around the circle and I peel it away, the circumference of the circle, imagine taking this and rolling it. This wrap came around the circle. So this is the circumference, which is 2 pi r. So you'll have to find this when you go to do your rectangle area. All right, and then we know how to find the area of our circles. All right, let's go. Let's flip it over. Got a calculator handy? Oh, I hope so. All right, so we can use nets to find the surface area of shape. So here's what we're going to do. How do we do that? We are going to find the area of each piece or each shape, each side of the net. and we'd add it together. I'll give you a second to catch up. We're going to find the area of each piece of the net, and then we're going to add it together. So the first thing we have to do is understand how to draw our net. Now, once you get that done, I need you to look at number 9 and decide how you think this thing is sitting, because I look at it 1 minute and I look back and it's sitting the other way. All right, what shape is this? It is a triangular prism. So we want to draw a net. So here's my issue. Do you have your triangular prism up there? So the question is, the prism one, I don't remember what color the base is. That's your pyramid. Yep, that's it right there. Okay, so the question is, do you see it sitting this way? Do you see it sitting on the rectangle like a tent? If you see it sitting as a rectangle, you have to flip it in your mind that this is the base and it's sitting up. And I couldn't see it, and then I just flipped it again. So picture this is the base, the rectangle, and this is sitting up. This is the height, like a tent. Does anybody see it the other way, where it's sitting on the triangle? But can you make it flip the other way too? No, I look back and it's like flipped, and it bothers my brain. Is anyone else seeing it flip back and forth? Yeah, it's weird. So it doesn't matter how you see it, whether you see it laying down with this popping up, or you see it top to bottom and this is the height of the figure. That doesn't matter. The idea is when I draw a net, I have 3 rectangles. Now, it doesn't tell us this, but we're going to assume that this is an equilateral triangle. Otherwise, it would have to give me more dimensions so I could find the area of the rectangles. So I have 3 congruent rectangles, which I'm probably not going to do a great job with. And I have 2 triangular flaps that are the bases coming off. Now, each rectangle is 10 by 4.2. 10, 4.2. And don't I have 3 of those? 10, 4.2, 10, 4.2. All right, so I have 3 rectangles. So the area of my rectangles, I have 3 of them, is base, 4.2, times height, 10. Okay, I could do better if you could actually see what I was writing. Now, we also have the 2 triangles, these bases. Now, if you read the extra thing, it says the height of the triangle is 3 units. Guys, I couldn't find the area of the triangle if they didn't tell me the height, or I had to use Pythagorean theorem and do 2.1 squared, because half of it plus 4.2 squared, or sorry, plus h squared equals 4.2 squared. They gave us a height of 3, which was very nice of them. Okay, so that means my triangle has a height of 3 and a base of 4.2. Now I have 2 triangles. So the area of my triangle, I have 2 of them. The area is 1/2 base times height. Now, remember, the area of a triangle, I would just double check it because some people were mixing it up. It's half the base times the height. But I have 2 of them. All right, so go ahead and find me the area of our rectangle. Use your calculator. It's times. I was thinking about using parentheses so the decimals don't get confused, because I think the decimals can sort of start looking like a dot. All right, what did we get? I think it should be 126, but I was making all kinds of mistakes. Does anybody agree with me? Okay, now what about the area of the 2 triangles? Well, 2 times 1/2 is going to cancel out. Should be 12.6. So we're really using the same numbers. 3 times 4.2, 3 times 4.2. All right, so then I add my areas together. 126 from the 3 rectangles plus the 12.6 from the 2 triangles. Nearest tenth is 138.6. And then what would I label this? Did it give me a label? It said units, so it'd be units by itself, units squared, or units cubed. Didn't we find surface area? Which is just area, so units squared. We only took and multiplied 2 dimensions, length and width, length and width. All right, fabulous. What's this next Next shape, it is a cylinder. So it's comprised of two circles, and then if you can picture this unrolling, it'd be a big rectangle. Okay, now let's go ahead and sketch this. Here is my rectangle, and here are my circles. Now, you can have a circle here and here. You can have them offset. They can be in the middle. It really doesn't matter where your circles lie. What is this part of my can? Do you mind grabbing our cylinder? See how the cylinders, flip that cylinder on its side. This is what we're seeing in the picture, but my net, I flipped it up right. So go ahead and flip that up right again. That's my net. So if I took the lid off, the radius is 6. Do you agree? Because the diameter was 12. Where does the 28 go? Does it go on the height here, or does it go on the length here? It goes on the height. So can you picture picking the soup can up, or whatever, barrel up? And this is the 28, and this is the 12. So the 28's the height. So here's what I don't know. What do we say to do for this? It's the circumference. And one way to help yourself think about that is think about rolling this circle. It's really, if you start here and roll it, what's the circumference? Okay, so what's the formula for circumference? 2 pi r, which is 6. So let's do nearest hundredth. Nearest hundredth. Where's my calculator? 2, I'm going to use my pi key. 2 pi 6. Now, I get this 37.699. So if I went nearest hundredth, the 9's going to roll it over, so it's going to be 37.7. Okay, now I can find that. So let's find the area of my rectangle. Area of the rectangle is 28 times 37.70. And then I need the area of my circles, but I have 2 of them, right? Now, what's the formula for area of a circle? Let's reference it so we don't mix it up with circumference. Area is pi r squared. So pi times 6 squared. And I have 2 of them. All right, let's throw that in our calculators. The area of the rectangle is pretty big. I have it as 1,055.6. And the area of 2 circles I have is 226.19. So now I just need to add those together. So I really have all 3 shapes. 1, 2 for the circles, and 3 is the rectangle. All right, so what are we getting? Oh, and it's not. So I'm adding up all the areas. My final answer is surface area. And that should be 1,281.8. Does anybody agree with that number? All right, what would you label it? Centimeters squared. Yeah, I guess I should have labeled this top one surface area too. Okay, flip it over. And let's read this problem. Oh, before we read this problem, I lied. Come back to me. On your formula sheet, do you see it says find the area of 2 circles and add the area of the flattened rectangle? I thought you guys might want to add a little bit here. The area of the rectangle is base times height, and for us, it's going to be the area equals circumference times height, okay? Because the base is your circumference. We have our height, and then I reminded you have the 2 circles, and you find the area there. So I thought that was a nice reminder. So your formula would be add 2 of these and the area. So you do have to do a little work. There's not like a perfect formula, in case you want to add those little notes there. All right, once you're done adding those notes, go ahead and read example 11. All right, I'll move this back if anyone needs it later. Okay, now here's the problem. When I wrap gifts, I always have overlap, don't you? Like, don't you have overlap? And I like to fold the edge, and when you do the sides, you fold up the sides. We have no overlap. We are literally just, almost cutting out squares to fit on this box. Got it? So we want the minimum amount of gift wrap. So no overlap, nothing like that. Good? We got it? All right, so let's draw a box. I think the easiest way to draw a box, I'm going to draw a rectangle. That's like the front of my box. And I think you have that square one, that one right there, the rectangular one. That's really what our box looks like. And I'm making this is like the front, like the red side's the front side. So yeah, that's sort of how my box looks. Now the easiest way to make a three-dimensional figure is draw your one shape. Sometimes I'll draw the back shape, but I'm just going to make this connect. So I'm drawing these lines out, trying to make them congruent, and then I'm just going to connect them. And you can see I had a little bit of extra there, so just ignore that. Then we're going to label our base, width, and height. Smiling because he's getting out of here. Okay, now I'm going to make the height 1 foot, and this, it doesn't really matter. I'm going to make the front the 3 feet and this side 2 feet. The dimensions really are not extremely important if we're just talking about a box, and I'm not worried about which ones are the sides or anything like that. Right, Taylor? Mm-hmm. Okay, so I need to find the surface area. I need you to picture what we have here. If you think about this box, I have a top part of the box and the bottom that it sits on, right? What's the area of the top? Well, it's the same as the bottom. Isn't that a 3 by 2? Forget about the 1. I just want what it's sitting on. So I have for top and bottom, the area would be 2, and I have it as 3 by 2. So it's sitting on a 6-foot squared surface, okay? 3 by 2, bottom and top. Forget about the 1, that's the height. So what's that give me, 12? Now, the area of the sides, as in the sides of the box, not what's facing us. I'm going to call these the sides. Well, I have 2 of them. I have one on this side and one on this side, and that's a 2 by 1. You see your rectangle on the side? I have 2 of them, and it's 2 by 1. Well, that's just an area of 4. So you have 2 feet squared, 2 feet squared. And then I'm going to call this the front and the back, like what's facing us. Front and back. Well, the front is 3, and isn't this also 1 foot tall? So I have 2 of those. 2 front and back. So 3 by 1, which is 6. So add these areas together to find the surface area. 12 plus 4 plus 6. So the surface area is 22 what? Feet squared. And there you go. Okay, now, if you would like a formula for this, you call this the length, the width, and the height, which if I'm going to use a formula, I label it length, width, height, so I don't keep repeating things. On your little formula sheet, I added that. So on your formula sheet for surface area of a box, rather than having to picture all the sides, which you should be able to do, the top and the bottom are 2 length times width. The front and back is the length times the height. Here's the front, here's the back. And the sides, if you want to call these the sides, I have 2 of them, and that's the height times the width. So because you're multiplying, it doesn't matter if you do width times length, length times width, but you're really doing every combination of LWH here, okay? And you have 2 parallel sides, so they're 2 of the same. So that formula might help you. All right, so once you have that down, let's read the next problem. It's again about a right cylinder. And I'll bring this formula sheet back up if you need it. So I'm going to draw my cylinder. Probably not the best, but I try. Doesn't have to be it's 100% not according to scale. But if I label it, the height is 1.5 feet and the radius is 1. Okay, now if they gave me the diameter, I'd have to figure that out. Now, if you want to draw a net to help yourself, I think that's fine. So here's my net. If I peel it apart, I've got the height of 1.5, and I've got the 2 circle flaps coming off of it. And each circle has a radius of 1. So we have extra work to do here, guys. In order to find the area of the rectangle, I need to find the circumference. That's what we were talking about. C equals 2 pi times 1. So this is truly like the base of your rectangle, which is round nearest hundredth, 6.28. So instead of doing base times height, we're doing circumference times height. I only have one rectangle, so it's 6.28 times 1.5. All right, so take your 6.28 times 1.5. Oh, I lied. Yeah, I did 6.28. And what do we get here? I think it should be 9.42. But you should check me because I royally was screwing this up earlier. Does anybody agree with me? Okay, perfect. All right, then I have two circles, right? So the area of the two circles is going to be 2 and then pi r squared.
What's in the parentheses?
These parentheses, which parentheses here?
Yeah.
1, because it's 2 pi r, so the radius is 1. Okay? And that's all I was doing was 2 pi r. And the reason I have the 2 here, the area is pi r squared, but I have 2 circles. So that I don't want you to confuse that with circumference. All right, so what do we get here? This is also 6.28. Just happens to be the same because I have 2 circles. So the area is 3.14, but 2 of them gives me 6.28. So add those together. My rectangle, or the label if you want to picture it that way, plus the 2 circular flaps, and I get a surface area. I have it as 15.7. Anybody agree? What was the label we were given? So it'd be feet squared. Okay, read the next problem and look for the big. There's two twists in this. We're almost at the end. One, you're only painting the walls, so what are you not painting? The ceiling and the floor. We're not talking about windows. We're just pretending it's like a closed-in room, no windows, anything like that. Next, how many coats of paint are you doing? So whatever area we get, we're going to double it. Do you catch that? And I think that's an easy thing to forget. So I'm going to underline this, and I'm just going to, underline that even though it was underlined. Okay, so I'm going to picture a room. Now, the only problem I have with this, it didn't specify which one was the height, which makes a big deal in here. Which one in real life would be the height? 12, 16, or 8? In real life, what are you thinking? Taylor?
Put 12 by 16 by 8.
Yeah, I know, that's what it tells me. But I just thought maybe you were, not paying attention, so I wanted to see if you could answer my question. I know I was. Don't pick it up again so I don't have to write you up. All right, now that the hammer's down, what are you looking at over there? Real life, what would be the height? 8 would be the height, okay? I think they should specify, maybe you do have super tall ceilings, but 8-foot high ceiling is standard. This is not 8-foot high ceiling. I believe it's much more like probably closer to 12 or so. But in a house, I would say 8, no, is 8-foot height? Maybe it's a little taller. Yeah. So 8 feet, we'll go with 16 because I made it look like that, and 12. The 16 and 12, it doesn't matter. But the 8's the big deal. So I'm going to make that the height. And normally you do get length, width, and height. That's typically, so they should tell you length, width, and height respectively. Okay, so if I'm only painting the walls, that means I have the front wall and the back wall. So I have 2 rectangles that are 16 by 8. I am not painting the 16 by 12. Do you see that? So the front wall is 16 by 8. So I think having the 8 there helps me not pick that up. 2 that are 16 by 8. And I'm going to add to that the 2 side walls that are 12 by 8. but I'm not finding the total surface area because I'm not doing the top and bottom. And remember, the bottom and the top would be 16 by 12. Okay, so let's throw this in the calculator and let's find the surface area. I guess this is surface area, not because I didn't split it up. And if you put them together, what do you get? It should be like 4 something. 448. And it'd be feet squared. Now that's great, but that's the surface area or the area of just the walls. And how many times are you painting them? Twice, right? So the 2 coats would mean that you have to take 2 times your area. And that gives us 896 feet squared that need painted. So it's almost like you're painting 2 rooms of the same dimension. Okay, so go ahead and read the next part. Now, if you're an avid painter, you could probably estimate, like someone could come in here who paints a lot and they could give a good estimate of how much paint you need, okay? They can also look at the wall and be like, this has never been primed before, we need to prime it, or you need paint with, like, some material sucks in the paint, so you have to use more paint. But if most standard things, if you actually read about a gallon of paint, it will tell you about how much area it covers. So you go in with an estimate of your area, and we have 896 as our area, and we want to see how much paint do I have to buy. So picture sectioning off a gallon of paint, we get 350 feet squared out of it. So I painted like a wall and a half, right? Because I take the 350 out of here, and don't I have to keep painting? So I'm really doing division, guys, repeated subtraction. Take the 896 feet squared from the 2 coats and divide it by the 350 square feet. And I get 2.56. Now, I can't buy part of a gallon. We're not going to buy quarts. It says 1 gallon covers this. We don't know about the other sizes. So how many gallons do I need to buy? Now, if I only buy 2, it's going to be shy. Don't I have to round up? Now, even if this was 3 or 2.1, you have to round up. You break the rounding rule of 5 and up, give it a shove, or 5 and above, give it a shove. I need to buy 3 gallons. Now, that's not what it asked, though. It asked for the cost. So we're not worried about tax. What's the cost? It's each gallon is $18. So, anybody? $54 in paint. And that's actually a really good deal because we're not worried about tax. But it's a good deal because that's pretty cheap paint. You're not going to find paint that cheap. All right, fabulous.